Have you ever wondered what the biggest black hole in the universe actually looks like? Not the black holes you've seen in movies, not the ones that swallow stars, but a cosmic monster so unimaginably massive that it makes our entire solar system seem smaller than a grain of dust. Somewhere in the observable universe, there are black holes so enormous that light itself cannot escape their gravity. They don't simply consume nearby objects. They shape entire galaxies, influence billions of stars, and challenge everything scientists thought they knew about physics. But here's the most incredible part. Every time astronomers believe they've found the largest black hole ever discovered, the universe surprises them with something even bigger. To understand just how enormous these objects are, let's start with something familiar. Our sun contains more than 99% of all the mass in the solar system. It's so massive that more than 1 million Earths could fit inside it. Now imagine a black hole with the mass of 1 million suns. Already, that would be almost impossible to comprehend. Now multiply that again, and again, until you reach tens of billions of suns packed into a single object. That's the scale of the largest black holes humanity has ever observed. One of the most famous examples lies at the center of a gigantic galaxy located hundreds of millions of light-years away. Scientists estimate that this supermassive black hole contains tens of billions of times the mass of our sun. Its event horizon, the point of no return where not even light can escape, is larger than the orbit of Pluto. If our solar system were placed inside it, every planet, every asteroid, every comet, even the sun itself, would disappear without ever reaching the edge. And yet, even that isn't the end of the story. Astronomers continue discovering black holes that seem almost too massive to exist. According to current theories, growing a black hole to such extraordinary sizes should take billions of years. They feed by swallowing gas, dust, stars, and sometimes even other black holes. But some of the largest known black holes appear to have reached incredible masses much faster than scientists expected.
How?
No one knows for sure. Some researchers believe they formed during the earliest days of the universe, when enormous clouds of gas collapsed directly into giant black holes before stars even had time to form. Others think repeated collisions between galaxies allowed them to grow continuously over billions of years. Either way, these cosmic giants remain among the greatest mysteries in astronomy. The frightening reality is that black holes aren't rare. Almost every large galaxy appears to contain one at its center, including our own. At the heart of the Milky Way lies Sagittarius A*, a supermassive black hole containing around 4 million times the mass of the Sun compared to the largest black holes ever discovered. Sagittarius A* is surprisingly small. In fact, some of the universe's biggest black holes outweigh it by more than 10,000 times. Imagine standing near one of these monsters. Long before reaching the event horizon, gravity would stretch space itself. Time would slow dramatically compared to someone far away. Entire stars would orbit the black hole at incredible speeds, while superheated gas spiraled inward, releasing more energy than entire galaxies. If you somehow crossed the event horizon, there would be no turning back. No signal could ever escape. No message could ever return to the outside universe. You would simply disappear. But what happens beyond that point remains one of the greatest unanswered questions in physics. Some theories suggest everything is crushed into an infinitely dense singularity. Others propose entirely different possibilities involving quantum mechanics, hidden dimensions, or even unknown regions of space-time. The truth is, no one has ever seen inside a black hole, and perhaps no one ever will. Yet despite their terrifying reputation, black holes may actually play a vital role in the evolution of galaxies. Without them, galaxies might never have formed the way they did. Their gravity influences billions of stars, helping shape the very structure of the universe itself. The biggest black holes are not simply cosmic destroyers. They are architects of galaxies. Silent giants that have existed for billions of years, long before Earth was born, and that will likely survive long after our sun has disappeared. But if these are the largest black holes we've discovered so far, what if even bigger ones are still out there, hidden in the darkness between distant galaxies, waiting to be found? And that's where the story becomes even more unbelievable. The largest black holes don't just consume matter. They can influence entire clusters of galaxies spread across millions of light years. Their gravity is so immense that they affect the motion of countless stars, enormous clouds of gas, and even the evolution of neighboring galaxies. In many ways, these cosmic giants act like invisible engines, quietly shaping the universe over billions of years. But here's the strange part. Black holes themselves are completely invisible. They emit no light, no color, no reflection. So how do scientists know they exist? The answer lies in what happens around them. When gas and dust fall toward a black hole, they don't disappear immediately. Instead, they begin spinning at incredible speeds, forming what is known as an accretion disk. As this material spirals inward, it becomes so hot that it shines brighter than entire galaxies. Some supermassive black holes also launch enormous jets of energy from their poles. These jets travel at nearly the speed of light. They stretch for hundreds of thousands, sometimes even millions, of light years into space. To put that into perspective, if one of these jets were pointed across our galaxy, it could extend far beyond the Milky Way itself. Few objects in the universe are capable of producing so much energy. And yet, the black hole isn't creating that energy. It's simply releasing the incredible power stored inside the matter falling toward it. The faster it feeds, the brighter it becomes. This is why some of the brightest objects in the observable universe aren't stars. They're quasars, distant galaxies whose central black holes are consuming enormous amounts of material. From billions of light years away, these quasars shine so intensely that astronomers can still detect them across the vastness of space. Some of the light reaching our telescopes today began its journey before Earth even existed.
Think about that.
When those photons left their galaxy, there were no humans, no dinosaurs, perhaps not even our solar system. And only now, billions of years later, are they finally reaching us. That's why every observation is like looking back through time. The farther we look into space, the farther we look into the past. And that's exactly what has confused astronomers. Some of the earliest quasars ever discovered already contain black holes with billions of times the mass of our sun. According to current theories, they simply shouldn't have had enough time to grow that large. So how did they do it? Did they form from gigantic clouds of collapsing gas? Did they merge with countless other black holes during the universe's first billion years? Or is there a completely unknown process happening in the early universe that we've yet to discover? These questions remain unanswered, and every new telescope seems to raise even more. The James Webb Space Telescope has already begun revealing ancient galaxies unlike anything scientists expected. Some appear far larger, far brighter, and far more evolved than our models predicted. Could hidden supermassive black holes be responsible? Many astronomers believe they could play an important role. If that's true, then the biggest black holes in the universe may also hold the key to understanding how the first galaxies were born. In other words, by studying the darkest objects in existence, we may finally uncover the story of how light first filled the universe. And perhaps, somewhere beyond the limits of our current observations, lurks a black hole so unimaginably massive that it makes every black hole we've ever discovered seem small by comparison. A true cosmic giant, waiting for humanity to find it.